Hello. In the previous video, I explained the conceptual framework of statistical hypothesis testing. I compared the statistical testing with presumption of innocence or Copernican revolution or your decision making when you choose between new item or familiar item. So now I will be more it'll be more statistical in this video. I use the same example again. In chapter 5, we started this example. At that time, we considered overbooking example as an example of binomial distribution, and we consider a similar, almost the same, identical example. Suppose that an airline allows free cancellation of reservations. Doesn't need to be airline. You may think about a restaurant or a hotel, whatever, any kind of reservations. But let me just call this an airline. So an airline allows free cancellation of reservations. So, and assume that the airline knows that some passengers, some customers may cancel their reservations accidentally, like unintentionally, due to emergency, with 20%. So 20% is the probability that a reservation is canceled. And as usual, we assume that reservations are statistically independent with each other. But what we are going to do here is, okay, this airline is okay with 20% accidental cancellations. But there are some abusers who make a lot of reservations and cancel later. So they knew that they are going to cancel their reservations when they make the reservation. Still, they reserve a ticket so that others cannot take that seat. And later they cancel because it's free. So we define abuse in this way. Then the airline, or the problem to the airline is to identify those guys. They want to identify abusers, and we may apply the statistical hypothesis testing framework in this case. So let's think about two customers. There are two customers using this airline, and they are both suspicious. We would like to choose one who is more likely to be an abuser, using in the statistical sense, in the probability sense, who is more suspicious. Customer A so far in the past made 5 reservations but canceled 3 of them. And customer B made 100 reservations but canceled 30 of them. So there is no correct answer here. Just think about this problem. Between A and B, if you have to ban one of them, then who would you ban from your reservation system? Just think about this. You don't need any algebra. Typically, I guess I understand a natural way of thinking is to think like this. Customer A canceled 60% of reservations, and customer B canceled 30% of his reservations. So 60% and 30%. So customer A canceled reservations more frequently. So customer A is more likely to be an abuser. That's one rationale, which makes sense. But let me show you a totally different way to think about this problem. So first, we have to admit that we don't know if they are abusing or not. This is all we observe as the airline. The airline company only observes who is canceling and who is not, how many times they canceled, but they don't know why they are canceling. So they don't know if it's abuse or not. So then the problem is, even if they are not abusers, they just happen to they have to cancel their reservations for some reasons. For other reasons, they may be sick, or they may had some other accidents, or something other things may happen. So it may happen. So these guys may not be abusers, and still the customer A was very unlucky to have accidents 3 times out of five reservations, which is very unfortunate. And customer A is innocent; he is not an abuser, but we cannot, we don't know the truth at this point. So, but what we know is, if they were not abusers, we know the probability distribution. We know the probability distribution of the cancellations. So the number of cancellations follows a binomial distribution, which is the same result as we considered in chapter 5. I have used the same example in chapter 5. So you may want to go back and review the example. And what we are going to here is, we are going to use this binomial distribution and calculate the likelihood of accidental cancellations. So what is the likelihood of a consumer who made 5 reservations cancel 3 of them? We can calculate that probability. So think about that. I already did it. So this is the distribution for accidental, like unintentional cancellations if a customer made 5 reservations. So remember, 20% is the probability. On average, 20% of reservations are canceled unintentionally, like by accidentally. So then only 32.77% of customers do not cancel at all. And more than 40% cancel 1 out of 5. And two cancellations happen with more than 20%. So they are very likely. So, but as you can expect, of course, the probability goes down as the number of cancellations increases. So canceling 5 out of 5 reservations is only 0.03%. So these guys, 0.03% of customers are innocent. They are innocent, but just they are super unlucky. They were sick 5 times. Whenever just happened to be the reservation date. So anyhow, we don't know who is abusers. So seemingly to the airline company, they are very suspicious. We don't know if they are intentional or not. Just they are suspicious. There is no other way. Like, even if they say I'm really innocent, but it's hard to believe, because it's hard to believe they are that much unlucky. How can you happen to be sick like 5 times in a row? That's very unlucky, so we cannot believe them. So this means they are more suspicious as the likelihood decreases. Likelihood decreases, so they are suspicious. And second most suspicious, third most suspicious. And so the more unlikely, the more suspicious. That's the main idea, our main theme, main principle in statistical hypothesis testing. Then now, suppose that you are planning to ban some suspicious customers from making reservations. You would not allow those customers to make reservations anymore. So if you choose to ban those who canceled all 5 times out of 5, then you are going to ban 0.03% of customers, right? Other than abusers. So 0.03% of innocent customers will be banned because they are suspicious, and they cannot prove themselves innocent. If you choose to be more strict, then you may ban those who cancel 4 times or more out of 5. Then you are going to ban these two groups, which is 0.67%, right? 0.67% of innocent customers will be banned. So there is more collateral damage. And finally, if you be more strict, then you can ban like everyone who canceled 3 or more reservations out of 5. Then you are going to ban these three groups, and the total probability is 5.79% of innocent customers. So then, as you can see, what you need to do here is you just need to choose how much you sacrifice the innocent customers. If you don't want to sacrifice, if you don't want to ban innocent customers, you have to minimize the banned innocent customers, the probability of banned innocent customers. So you have to choose this. But if you don't care about those innocent customers, you may choose this. So it's up to you which percentage you choose. All of them are suspicious. It's just a degree of suspicions. So it's a ranking. Most suspicious. So these guys are most suspicious, and second most suspicious, and third most suspicious. And where you draw the line. You have to draw the line. That's your subjective choice. But statistically, you can express the measure how strict you are or how suspicious they are by this probability. So you have to choose how much customers you are going to ban. To ban customer A, you have to ban 5.79% or more customers. So this is the rank of customer A's suspiciousness. So customer A is here. To ban this guy, you have to ban everyone here, right? So if you ban from the most suspicious, you have to ban all these guys. So then in the end, you are going to ban 5.79% of customers. So then you may define this probability as the probability of more suspicious customers than customer A. So customer A canceled 3 reservations out of 5, and then you may calculate the probability for 3 or more cancellations. That means at least 5.79% of customers are more suspicious or at least equally suspicious as customer A. It's very complicated, but if it's to think about this again and watch it again, I try to make it as easy as possible. So this is the rank. So customer A is if there are 100 customers, customer A is 5.79 rank, top 5.79% suspicious. That's the rank. Now you can do the same thing for those who make 100 reservations. For 100 reservations, the distribution is also a binomial distribution, but the parameters are different. So the probability looks like this. Even though it seems like there is nothing, but there is a very small probability, 0.00001, on each of the values. So it becomes more suspicious as they cancel more. So becomes more suspicious, and you have to draw the line. Where do you draw the line? You have to stop at some point, and customer B is here at 30, and if you would like to ban up to customer A, then that includes 1.12%. So there are 1.12% of customers who are more suspicious or equally suspicious as customer B. So it's customer B is top 1.12% suspicious. the rank is much higher. So compare. Now you can compare. Among the customers made 100 reservations, customer B's suspiciousness is top 1.12%. So now you can compare. Among customers who made 5 reservations, customer A's rank was 5.79%, top 5.79%. Meanwhile, customer B's suspiciousness ranking was top 1.12%. So the smaller the probability is, the more top ranked. So the more suspicious. So if you compare these two numbers, customer B is more suspicious. Yeah, that's the conclusion. So if you may put it this way, if you plan to ban 5% of innocent customers, customer B will be banned because he is within top 5%, but customer A is not banned. He is not within the top 5%. So in that sense, customer B is more suspicious, right? So even if, like, go back, even if the cancellation rate is much higher for customer A, but customer B is more suspicious. I would simply, the intuition is like this. When the sample size is small, when you have small number like 5, then you can be unlucky. It may happen by your bad luck. It's possible, plausible. But when you repeat the experiment like for a larger number of times, like 100, then bad luck cannot explain the randomness. So when the sample size is large enough by the law of large numbers, the randomness goes away very much. So canceling 30 times out of 100 is not excused by the randomness. That's the main idea. I'm going to formulate this idea in more detail in the following video. So this video contains the main essential ideas of what we are doing in hypothesis testing. So please repeat watching this video and try to understand what I'm saying. If you still have difficulties understanding this, please let me know. I may talk more about this if you need more help. So see you in the next video. Thanks.